Hey guys, lesson 5.1, models for addition. Learning target today is that you'll be able to apply these models, which some of them will seem kind of no duh, but apply these models to the addition of variables. Let's begin with a warm-up. A couple of questions for you to answer. Again, these might kind of seem like no-brainers, like Mrs. Reba must think we're crazy, but yes, I expect for you to complete these questions. Taking a look, the most basic model for addition is called the put together model or the putting together model. Basically, it states to put together counts or measures of the same unit. That part is really important. With no overlap, we add them together. An example, we saw an example of this in the warm-up. It's super easy when we're talking about numbers. Little Susie has 2 cookies and little Ralphie has 5 cookies. How many cookies do they have together? 7. Kind of a no-brainer, 2 plus 5. This is actually not much more difficult, but slightly more difficult to wrap our brains around the idea. It's a little more difficult with variables. For example, if Grover has 6 oranges and Big Bird has B oranges, things get a little bit more complex. But in this case, it's actually pretty simple because we are just going to be determining that together they have 6 plus B oranges. It feels strange at first to not really answer the question, but by indicating that we would add 6 plus B, we have answered the question. Here's an example of putting together with lengths or distances. For this, we're going to be dealing with collinear points. You'll remember from our Chapter 4 dictionary that this means points that lie on the same line. So here we go. We've got 3 points that are collinear, E, H, and S. Essentially, I can know that the distance ES from E to S is equal to the 2 smaller distances here, E to H, and then H to S. So taking a look at each of these, that's what we're looking at. So here's a symbol alert that we need to take a look at. If you have a symbol indicating 2 points with no symbol above it, it's indicating a distance or a length from X to Y, or in reverse from Y to X. So if I were to tell you that ES is equal to 8, EH is equal to 2, you can find HS. Go ahead, press pause, and give it a shot. In this case, HS must be equal to 6 in order to make the entire length ES equal to 8. We're going to take another look at an example of putting together, this time with angles. Putting together with adjacent angles, those angles are connected with the same vertex. So here is a set of adjacent angles. Taking a look, essentially we have 2 smaller angles making up a larger angle here. We've got the angle ADB, the angle BDC. Together they make up the full angle ADC. If I add the measure of the 2 smaller angles together, it will give me the measure of the larger angle. So, if the measure of angle ADB is 93 degrees and the measure of angle BDC is Y degrees, what is the measure of angle ADC? This one is a little bit trickier maybe than the last one, simply because there's a little bit more to each of the symbol names. But take a look, read carefully, and we can find that the measure of angle ADC is equal to 93 plus Y degrees. Again, in this case, it feels weird to leave a variable in our answer, but it is exactly what we need to do. There's another model for addition, the slide model. The slide model is done on a number line where we can show how we can add numbers. This is used primarily when we're talking about adding positive and negative numbers. Positive numbers slide to the right or up if it is a vertical number line, and negative numbers slide to the left or down if it is a vertical number line. So for example, if we wanted to illustrate 4 plus 3, we'd slide to the right 4, slide to the right 3, since these are both positive numbers, indicating that 4 plus 3 is 7. Hopefully that isn't too big of a surprise for you. A little bit more handy when we're adding negative numbers. For example, negative 4 plus 3. Negative 4 would indicate a slide from 0 to negative 4 units long. And then we would slide to the right 3 units, indicating that negative 4 plus 3 is negative 1. We can try another one, 4 plus negative 3. The positive 4 would indicate a slide to the right, and the negative 3 would indicate a slide to the left. 4 plus negative 3 equals 1. And last but not least, in any of these examples that we've taken a look at, we can illustrate the commutative property of addition. The numbers can be put together in whichever order we choose. It doesn't matter if I add the 4 or the negative 3 first. I could have also done negative 3 plus 4. We would have ended in the same spot. That's something that we call the commutative property of addition. It says for all real numbers a and b, a plus b equals b plus a. This is true for multiplication as well, as some of you may remember. It is not the case for subtraction or division, though. This is true for addition and multiplication only. That's the end of our notes today. We'll see you in class tomorrow.